Yes, Sourabha, over
Okay.
to you.
Yeah, I'll start. Yeah. Yeah. So is it visible, the screen?
Yeah, it's visible.
Okay, sure. Well, hi folks. Uh, Good afternoon, and welcome to the second episode of this OOPS event being conducted by DSC IIT Bhubaneswar. And I'm Sourabha Bharadwaj, fourth year CSE undergrad. And in this episode, we will. Okay, wait, just a second. Sorry. Okay. Yeah, is it visible? I forgot to record. All right. Yeah. So in this episode, we'll be talking more about the further fundamentals of the entire OOPS concept. Let me first go to the quickly recap whatever we did in episode one. Episode one was hosted by Arushi, and I'm pretty sure she talked about these classes and objects and the what are access modifiers present and the others like advantages, disadvantages of OOPS. And I know like you have now a brief idea as to what classes are. They're simply a blueprint of a real world object. That's it. Like they have some set of fields, they have some set of methods, and you pack it in one class, and that's it. Your job is done. You need not specify something else somewhere else. Like that one set represents your entity. And coming to objects, now objects were proper instances, like real instances of a class. It's more like telling you write down the the properties and actions of an elephant on a paper. Okay, now that is your class, but you see a real elephant. Now that is an object. So it's just the similar analogy here between classes and objects. And we know that objects hold some data, they perform some actions, and with this class and objects comes another property, that is the modifiers. Like each class has a set of attributes. So those attributes you can declare private or public, where you provide access within the class, or you provide the access to the entire source code, or you want to give it in the same package. It's package in the sense it's a directory. Okay, so that's it. So then finally you were introduced into like what were the advantages and where to use OOPS and where not to use these things and all. So this was pretty much the quick review of episode one. Now let's dive a bit deeper now. Okay. So here you get to learn four important pillars, okay, of object-oriented programming. That is like encapsulation, then abstraction, then inheritance, and polymorphism. Like these are pretty much mouthful words, okay. And by any chance, if you feel like oops is not like you're not getting anything notes, don't worry. Just go to that site there in the link, and you will understand like how important these concepts are and how important oops is when you are trying to write responsible code. Like what I mean by telling responsible code is you join an organization and you write some important code there. It's very crucial, like how you implement these things and how is your idea, how is your design. And for all those things, these four important concepts where encapsulation, abstraction, inheritance, and polymorphism play a really important role. So if like it's a very simple concept, looks complicated, that's it. It's very simple concept, and once you master it, like you can you can really perform really well. It may be in interviews, it may be in internships, and finally also in your job. So okay, just see to it that you learn these things very nicely. Okay, it's very simple concept. Okay, so let me start off with encapsulation. Okay, now so yeah, before that, how I will be proceeding through this episode is that each module, say encapsulation, I first introduce the basic philosophy as to what is encapsulation and why it is used in these things. And then I'll walk you through some code that I have implemented, like live code I'll show you. And I have written that in Java this time. Last episode was in C++ to you by Arushi. And in this, I'll be showing you how to do these things in Java. And the reason I'm choosing Java here is because any modern application you see, any web application to be more specific, it is very easier. It is very, it becomes more meaningful if you do it using Java. Why? Because the OOPS through C++ is very important in time critical systems, or maybe in very much intrusive objects. Maybe like say you're doing medical and say you're trying to do some biomedical project, okay, and in that you're trying to invent some device. At those cases, using OOPS through C++ is very important, okay, because you need to manage your memory very well and you need to keep things very fast, and that is very important there. Even in video games, okay, any game you take up, it's very important to use C++ and OOPS through C++ there. But when it comes to web applications, right, it is very easy to automate these things through Java. So that is why I would like to encourage you to use Java in case you're trying to go for web apps. In case you're trying to go for embedded systems or such other crucial things, pick up C++. Anyway, it's the same, so there shouldn't be any problem. Just a slight implementation problems will be there. So yeah, I'll be going through the philosophy. I'll be going through the live code examples in Java, and finally I'll talk about some few examples. And there are like a lot of examples here so that you clearly understand these terms. Okay, there won't be any confusions after this. Okay, let's dive. Let's start with encapsulation. The moment you see this encapsulation word, the thing that highlights is capsule, right? And this is a very common word where we see that you pack in a lot of things in a single entity. That's all we try to understand from this word encapsulation. In the sense, yeah. So what is the basic philosophy in encapsulation? You have some data, okay? A class is having some certain data, and you want the data to be handled securely, okay? What I mean by securely, you'll understand in the live code example. Okay, I'll show that. But you want it to be handled securely in the sense, some data fields you want to give access to other classes. Some data fields you don't want any access from any other foreign classes. You just want it to be within the same class. And even if you want to change it, you allow restricted change, okay? Now, when you have these two requirements, right, the moment you realize that you need these two things, it means you're trying to encapsulate them. What does that mean? Typically, it means that you're trying to declare, okay, all of these as private, those fields. And if you declare private, you would have understood from the previous episode that the moment you declare private, right, it becomes so difficult to even access. You can't say cout, say elephant dot weight. The dot weight, if you have declared weight as private, it's impossible. Okay, it's impossible to even print it. Only if it is public you can print it. Then how can you even access the data? Does that mean that once you enter some data into an object, it is gone forever? You can never access it? Well, it is no. You can access it through two things called getters and setters. Okay. Now, what does it mean? I mean, the name itself tells, like, getters in the sense you get the data from the object. Setters means you're trying to set. I mean, you want to change that particular data of the object. Okay. And one thing you need to remember is you don't want all the fields to be able to be modified by other classes. Only selected of them. And remember one thing. So you make them private. You introduce getters. You introduce setters. When you do these three things, what does that mean? That means now your data can only be accessed through method calls. There is no direct interaction of the data from another class. Fine, that is checked. Second, that means you know who is actually calling that particular function of getter or setter, who the caller is, what was called, what was set. All this data is in a very neat form in the stack trace. Like if you want to explore the stack trace, you get to know that, okay, this function called this function, this changed this, and this was a result of this. So it becomes very easy to trace the changes made to a particular object, which in turn means when you create a large scale application, that means it becomes more cleaner, more maintainable, and the most important here is more testable. Okay, you can test your code very well. And to be more specific, in your fourth year, right, I mean the seventh semester, you have this course of software testing, when it's an elective of software testing, you get to know that it's very important. I mean, how important testing is and what are the different ways of testing. Okay, there is something called like JUnit tests. These are very crucial in ensuring that your application doesn't, misfunction at times, and how to ensure that you handle all the test cases and corner cases, all these things. When you want to do these things right, it's very important to do it through a proper structure, and that is where you use the concept of encapsulation, right? So this is a basic philosophy. Let me actually show a live example for this. So I'm switching to the editor now. I hope this editor is visible.
Yes.
Okay, yeah, thanks, Ashay. Yeah, so let me first go through this class called encapsulation I have declared. Now let's say our aim is to mock the popular app Gmail, right? This is our aim. So let me go to the class definition here. Class declaration there. So I have declared 4 fields, okay? 4 attributes called full name, username, password, and full email. 4 things, all strings, okay? And then I have declared it as private, okay? So the moment you see private, I know you get to know that it's impossible to access it somewhere from the foreign class the moment you instantiate the object. Now, I know, I hope you all know that this segment here is a constructor, okay? Now, this constructor is taking in 3 arguments: full name, username, password, setting it here, okay? And finally, I'm creating a new, I'm updating the field of full email by telling that username @bmail.com. Fine, this should be fine with the constructor. Now, for now, don't worry about these things. I'll come to that later. Let us go to the main class, okay? If you don't know Java, it's totally fine. Just remember that this whatever is there in this main, right? That is simply whatever you do in int main in C++ or C. It's pretty much the same. Okay, don't worry much about the syntax. Okay, it's totally fine. Now, here you can see that I have created a Bmail object, account1, and I have fed in 3 names and 3 things like Alice Nova is a name, username is Alice123, password being QWERTY. And I have an account 2, Bob Ross, Bob the Builder, Ice Cream Pizza. Fine. So now so you created the object, right? Now, as I told earlier, the moment you declare private, it becomes impossible to print it. So as you can see in line number 42 here, you just can't do this. Let me uncomment the thing and show you actually what happens. When I do this, then the ID just says that, see, full name has a private access. Okay, that means you really cannot access it. Then how do I get it? Well, that is where you come into this function, as you can see, get full name. Okay, let me just go to the definition of that get full name. Yeah, in the same class definition bmail, I have a method called get full name. So here I'm just doing, there is just one line which says return full name. Okay, it's just return full name, which means the full name which was there in this which is the field of the object, is now indirectly being accessed through the getter, that is get full name. All right. Similarly, you see another function, get full email. Okay, which means it just returns your full email. That is fine. So the same things. The same thing you do here also. And I just print out account1.get full name, account1.get full email. But one thing you would have observed here that I have set the password. I set the password here, but I haven't given any the method to actually access that password. There is no get password. Even if you try to just uncomment this and just say account1.get password, it says the function is not declared. It cannot resolve the method. So one thing you can realize, what is the crucial thing here, is that you allow access to only specific data that you think is required by the API points. You think it's so obvious that it is okay to give the full name and the email to a foreign class, but not the password, right? You don't need to share the password to other users or something. But then you will come to the other question that, fine, then if I don't give the password, then when I re-log into a website, then how do I actually validate that password, right? When I can't access it only. I'll just write a function for it. There is no necessity that you need to get the password, then check it, and then return it, right? You can instead make that functionality within the same class. So as you can see here, I have written a small function, a validate password. It just takes in a password which you entered and just checks like password of the class dot equals the entered password. As simple as that. And it is a boolean, so it says whether it was true or false. I mean, if it is the same password, it is true, else it is false. Now, so this means you can perform so many applications, so many functionalities without actually giving full access to the data, which pretty much means that you have encapsulated, okay, you have secured your data. You're not disclosing it to all, disclosing all the data to the foreign classes, or limited access is given. So in this way, you can actually validate, perform so many applications with much security. Now suppose, okay, let's come to another scenario where, fine, you logged out and somehow you forgot your password. Okay, you need to change the password. There will be this forgot password thing. For that also, say after some security checks, okay, normally you have some multiple security, like you get some message, you get some email, these things. I'm not writing those things, but ultimately what happens is you enter some password that needs to be set in your object. Now I'll allow only that part, right? I just say account1 dot set password. Say you want to give incorrect, okay, that's what your password is. So account1 dot set password as incorrect. This means you are changing the password of the object with only one single method, set password, which possibly is having a stack of some security checks. Fine. So you change your password and you might also validate it later. But then you might think, okay, what if I want to change my username? Okay, you could change the password. Why not change my username? But that I don't give access on. I just like it is. So first of all, this thing is impossible. You cannot make like account1 dot username is Alice234. Impossible, right? Because this is already a private field. You cannot access it. Fine. You might say, okay, well, what if I check for set username? Even that method is not there because I haven't implemented at all, right? This means once you created your account, you signed up much earlier, right? There your object was created in the application, and that was the place where you gave your full name and your username, and that's it. It's impossible to change anywhere else in your entire application, even after some 10 years, I don't care. So this means you have given so much of a restriction to the actual data that is present in the object. Like only the password you can change, and you can only see your username and full name. So I hope you got the good idea of what is why it is so important that you give proper getters and setters, not getters and setters to all the fields. Only to restricted fields you give getters, only to restricted fields you give setters. Now, if you still think that, okay, this is kind of not important, I'll just give you a very simple example, very simple example. It's called like encapsulation nemesis. Okay, before that, let me just run this code, okay, and show actually what happens. So we run this thing. Okay, what happened? Yeah, sure. So now it gives you things like your user one. So I access this thing using get full name, and I got the name here. I use get full email. I get this alice123@gmail.com. Okay, and I have set the password. So initially my password was QWERTY. Now somehow I misspelled and gave QVERTY. Then it says false. I mean the password didn't match. And finally I reset the password to incorrect. And then I say whether my password is incorrect, and it says yes, it is incorrect. Okay, so that is why it says true. Okay, it's just a play of words. Cool. So this way it becomes so manageable. Okay, like you can see the cleanness over here, right? Only restricted access, restricted getters. Now, if I go to the other scenario, right? What if I don't set up any of this encapsulation? What does that mean? I'll go to this simple C++ code, and I hope you all, at least I can understand these things where you have a map, like what you use as a map and as a vector. If you don't know what is map and vector, it's totally fine. See, like map is just a table. Okay, you have some ID. You have just two fields in my map, which is just like an int. It's like a serial number, and I have another column called vector. It's just a list of some data. Okay, and I'd like to keep it as all B mailers. Okay, now one thing you observe here is that this is a global variable. Okay, And the moment it is a global variable, it means any function can access it without any restrictions, right? So say in my main function, I create an account. It's like in my serial number 1, I give data as Alice and Alice 1, 2, 3 and QWERTY. And account 2 is the same thing I do. But then I can really change this data at any time. Like I can simply write this all B mailers at index 1, change the name to Max. So my name just got changed like from Alice to Max at any point of time. Now, this is fine if you see like here's hardly 20 lines of code, but then if you take up like when you have millions of lines of code, right? If at some point this change happens, then it becomes so difficult to trace as to where the error was. Okay, because here you are giving public access, like any function from anywhere can access it and change the data. And if you still want to know, I'll just run this code, and I think I had actually compiled it earlier, so I'm just running it. Yeah, so as you can see, initially it was Alice and QWERTY. Now since you changed, it became Max and QWERTY. So the entire data is gone. I mean, you have lost the data. So this actually shows how important it is to encapsulate, is actually hide your data from foreign classes and other corrupt functions. Okay, so this is the whole philosophy of encapsulation. Okay, where you give restricted access, and this is some example. Like just look into the last line where what is encapsulation in the sense you have all these fingerprint, right? Like you can give multiple copies, like there's like getters, okay, but you can never set your fingerprint. Okay, like there's no setter function for your fingerprint. So okay, this is just a small example. Okay, so finally, like what is encapsulation? I hope you have got it. Let me just see if you have any doubt. Like just log it in your comment section. Like, do you have any doubt? Okay, Python does not support encapsulation. No options to make variables. There's private or public. Everything is accessible if you call them. So it should not be called as an object-oriented language also, right? Not really. Like Python is also an an object-oriented program. See, that's what these oops or whatever is there. It's more of a philosophical topic, okay? Where you have what to say, like you have some set of principles laid down, but the implementation is different in different languages. Like in C++, it's implemented in different way. I'll come to one point where it's not possible in Java, but then it's possible in C++. So does that mean Java is also not an OOP language? No, like Java is most widely used OOP language actually. Also, like if you see Python, right, you're telling this thing like there are no options to make variables in methods or private or public. So like it's not really like that. There will be some methods to which you can actually do that. So we just need to look into the proper documentation. And in fact, let me tell you, like when you use machine learning, these things like libraries, right? Like you have Keras and TensorFlow. Like there, when you want to create layers, right? It's not that you're simply calling some methods. Like there, you're creating objects. Okay, so OOP is there in Python also. Okay, it's not that you cannot call it, but they're implemented in a slightly different manner. Okay, there'll be some very deep concepts you need to go through it. Just go through the documentation, you'll get to know how it is.
Yeah, Sourabha, I will like to add something. In Python, instead of explicitly writing public or private, there is a just different way of naming the variables in order to declare them private or protected, something like that. So maybe Samir, you can look up Geeks for Geeks, you'll find it.
Yeah, that's there. Yeah, true. Thanks, Asher. Yeah, I mean, yeah, that's what you go through the documentation properly, and you get to know a lot of things. Like you just you look up some code doesn't mean it tells everything, right? The documentation is the important thing here. Okay, fine. Like any other doubt in encapsulation regarding the concepts, like did you get it? Any other problem? Any other questions? I'll count till 20, maybe 1, 2. Any doubt, you just type in over there. Okay, I'll just go through. Okay, yeah, but we can still call them even after declaring them by using underscore. Okay, double underscore. Yeah, before variable names. That's what confuses me. Well. Yeah, that is actually there. Well, I have done more with Java. Python, I'll definitely look into it, man. Yeah, Samir. Yeah. I'll look into it definitely, and I'll revert back to you. And work very less with OOPs in Python or with Java. That's fine. I'll let you know like right after the session. Cool. Okay. Any other doubts? Okay. All right. Seems like there's no doubt. Fine. So, yeah, the next topic here is abstraction. So first you learned about encapsulation, where you got to know how you can hide your data points and give limited access. Now coming to abstraction. Okay, so I hope like pretty much by from the word itself you'll get an idea that abstraction is where you provide an abstract view, okay, like an overview of a complex entity. Okay, what does that mean is, yeah, you say, okay, you have objects where you have some n number of attributes which are common to a group of objects, okay, and they all perform some number of functions, say m number of functions are there. So what you think is when you're designing the application, well, let me organize all of this, okay, like those n features and m methods into a single unit or single entity. But then you realize that, okay, some methods may be common, okay, may be exactly same to for all these objects, but some methods may have their own implementations, okay, when you create those objects from that class. So that means what? You want some methods to have a common implementation among all the group of objects, and some implementations to have, I mean, some implementations to be custom, to be specific to that particular object that you created. Now, so this leads to a confusion that only through encapsulation, how can I do it? Okay, so that brings in this concept of abstraction. Okay, I mean, in fact, abstraction is more of a very light topic where you just abstract things out and place it in a single entity and just list it. You don't implement at all. Even if you want, if you want to implement only one or two class, whatever you want to say, you will implement, which should be common. Rest, it will be simply a listing. Okay, and the way you use abstraction, right, that comes in the next topic, that is inheritance. Okay, so but still I'll tell you there are two ways of using this abstract word. Let me just show the code again, how it is done, abstraction. Yeah, so first so yeah, I think you've got an overview, like abstraction means you have an overview of a complex entity. Just remember that. Okay, abstraction is an overview. Now, for this example, okay, of abstraction, I have taken a famous thing. Like I create two classes called Iron Man and Batman. Okay, fine. So now you know that. Let me keep common props. Like Iron Man has a name, and he has something called as a max power, and you have some current power. Okay, but one thing you need to observe here is that they're measured in some unit called volts. Okay, this is a new universe we're creating. Okay, fine. So his power is measured in terms of volts, whether it is max power or the current power. Okay, and similarly, let me come to Batman. He has three fields again: name, max power, and current power. And somehow in some weird world, he measures his power using bats. Okay, the number of bats he has. So it's like the max power he has, and also the current power he has is the number of bats. Now, so this is the object, my class where I have declared these fields, and you pretty much know this is a constructor where I'm simply setting stuff like his name, his max power, his current power, and there are two other fields. Okay, just forget the last field, just concentrate here. That's like get power level. Okay, and it is simply a percentage of the power level. Fine. Now I have another class called winner. Now what is the job of winner means? Let's assume, okay, we are trying to create a game, okay, where you have this Iron Man versus Batman happening. Now in that scenario, at any point of time, you say that, well, if some objects, okay, the object of Iron Man, he has a total power level less, okay, less than that of Batman. That means it is possible that Iron Man will lose. It's likely to lose. Iron Man will lose if his power level is less than Batman. Now, the problem here is they have different units of measurement, right? Batman measures his power through number of bats he has, whereas Iron Man measures it through the number of volts he has. Then how do you get a common platform to measure these two things to different entities? Well, that is where this abstraction guy comes in and he says, hey, don't worry, we will take a proper like it's fine. Like let Iron Man measure through volts, or Batman measure through bats, or the amount of money he has, whatever. I don't care. But ultimately, it's all about the percentage of power you have, right? I don't care what is there inside. Ultimately, I just need an overview of that, which is simply the percentage of the current power to the max power. That's it, right? Then you say, oh yeah, that's right. Yeah, like I can just take in the percentage values and actually measure it, compare it. This is where the abstraction jumps in and says, well, that's how you can simply abstract over those current and max power and get this get power level method, which simply takes in the percentage and gives you at any point of time. You need not worry about what they are doing inside. You don't really need to care. And that is where this winner guy comes in. He just takes in two data, like the get power level of Iron Man, get power level of Batman, just compare it. Pretty simple comparison, just print out statements, or you do any other complex, like million lines of code, I don't care. So basically, you saw the simplicity here, right? I don't need to understand what is going on under the hood. I just need to see what is there on the surface. So that is how abstraction is. Okay, this is one part of saying abstraction gives you an overview. Okay, and very much what to say, a simpler and common example is that you're driving a car and you just turn your steering wheel towards left or towards right. You apply brakes and acceleration. You don't really need to know how those hydraulics work over there and how the ignition works over there. What you just need to know is that I need to reach from here to here and I just need to turn right, left, or whatever. Right? So this is abstraction. This is abstraction where you only need to know the basic, like higher level, design level understanding of an entity rather than the implementation level concepts of the entity. Okay. So yeah, I mean, this is abstraction. One way of seeing abstraction, and I don't think I need to run this. Like, still run this code. I just need to see what happens. Yeah, it says like batsman name is Bruce Wayne, and Bruce Wayne also is likely to win. And maybe if you give same level, I don't know, just run it, and it says, yeah, okay, it says like people are likely to win because both are having similar powers. Okay, so because you'll enjoy a longer show. Fine. So this is one way of looking into abstraction. The second way is I'll like to. So this was what to say, implementation level abstraction. Like you didn't really care what was being implemented in, under the hood. There is something like called as the class level abstraction. Okay. Here. Here. So here you have this abstract class. Okay, this is something specific to Java. I'm talking again. Where in an abstract class, right, you just define some fields, okay, and you define some methods. I mean, declare some methods as like abstract public void revolve. So okay, forgot to tell. I'm creating a class called planet. So as we all know, like planet has some name, size, type, some set of satellites. Right? They revolve, rotate, manage life, whatever. Some functions are there. Now, as you can see here, like these properties were similar, are similar to all the planets we have, and they also perform similar functions. But the problem being, they implement these methods a bit differently. Okay, say one revolves in one way and revolves in like, okay, like say you take that in your own universe or whatever solar system. Okay, it's fine. And they manage life differently. So as you can see here, the implementations are specific to each planet, but the functions, I mean, the name of the function is the same. It's same as telling like person A can sing, person B can sing, C can sing, but maybe A will sing jazz, or he'll say rock, pop, whatever, classical, anything. But overall, they all sing, right? Now that sing you actually mention over here. That's it. You just specify that any planet has these three basic functionalities and it has set of features. That's it. And here deliberately I haven't mentioned here private. Like it's understood. Like you need to tell it private so that you don't allow wrong access. That is fine. So, but one thing you can actually observe here that I have actually implemented one method, and that is called the parent method. It says my parent is the sun. This is obvious that every planet here we have has sun as the major entity. I mean, the parent thing in the entire solar system. So it doesn't make sense when if you want a custom implementation of a parent, like my parent is sun, my parent is something and like else. It doesn't make sense, right? Like it is specific. I mean, it is common to all of these objects. So that is where abstraction comes in and says, okay, there are some methods which are common. There are some methods which are specific, but the point is that they all have some similar functionalities in names. That's all is abstraction. Okay. Now I'll go a little further and tell you how this abstraction is used here, and this is actually a property of inheritance. Okay, that's the next topic we'll be talking. But this is an overview, and I'll show you how it actually works. But before that, okay, you have any question, you can just type in like for abstraction. Any questions, any doubts? Like you understood, right? Like you just list in things which may be common to multiple objects, and you can implement. I mean, you do a custom implementation later. This is the whole philosophy of abstraction. Okay. Any doubts? Any doubts? Any doubts? Right. I think. Okay, I think I can continue. Fine, I'm good. Well, so yeah, you saw this, and to give a much better example, say you have Alice and Bob meeting for the first time in some country, and they say hi, hello, and they're like, "Where are you from?" "I'm from India," and that's great. Okay, this is a scenario of abstraction. Okay, he says that I'm from India, but let's take another scenario, okay, where he says hi, he says hello, he asks where you're from. You don't really need to give your full history over there. Okay, you need to hide your details and don't say I'm born in Bangalore, then got up in Chennai, and blah blah blah. Okay, and by the time Alice will move away, like, hey Jack, wait for me, he moves away. So what it means is you need to give an abstract idea of your complete entity, and that is what is another important feature when you're designing complex applications. It really doesn't look good if you implement everything in a parent class and then you present it to each and every other class which actually takes it. It does, because most of the code might become redundant, and it doesn't make sense to actually implement it again and do it. Like it doesn't look good. That is why it's very important to maintain clean code, testable code. That is the whole important concept that's powering OOPS. Okay. So let me go to inheritance, and I'll come back to the same example of planets. Before that, now coming to inheritance. Now you saw this previous example, right? Planets having some features and having some functionalities. What does that mean? Like, is it fine if I just declare a planet class, like an abstract class, and just create new planet and just pass in some name size? Actually, it is wrong. Okay. Why? Because you do not have any implementation to these methods. Like if you say, okay, earth.revolve. Now suppose you create a new object. Okay, let me just type in here itself. Suppose you will say this, okay, planet, okay, some earth is equal to new planet, and you pass in say the name as earth, okay, and then you say the size is something I don't know, I don't want to mention it. That's it. Okay, and then you have the type. You say it's rocky planet. Okay, and let me do this much. And suppose in your simulated game, suppose you're trying to build a game of like planets, and there you suppose you call earth.revolve. Okay, suppose you call this method. Do you really think Earth knows how to revolve in this scenario? No. Why? Because it's just an abstract idea that Earth will revolve. but it is not at all implemented anywhere. That means what? These abstract classes, you cannot create objects out of abstract classes. You must create subclasses out of that abstract class, and that process is called inheritance over here. Okay, you have class called earth that extends planet. What does that mean? Like, this is specific to Java, where you say that, yeah, I'm creating a subclass called earth whose parent class is planet, and the moment I say it inherits, right? The moment I say the moment I say it does this, I'm inheriting some properties. What do I mean by inheriting? Well, whatever you're seeing here, say like from line 24 to 39, 38, okay, all of this is kind of copy pasted, okay, into the earth class. Okay, so whatever properties and functions were there for the planet class, they're simply extended to the earth class. And from here, okay, from here you can have the earth have some custom implementations. Like, you can create an earth object, not a planet object, again earth object, and then you pass a name, type, and size, whatever, and then you have some implementations over here. Okay, so earth, if you see, it has an implementation for revolve. The moment you call earth.revolve, now the earth knows and the planet knows that it has to revolve around the sun, something like that. You can have some other implementation, just for explanation I've taken. Similarly, if you want to say rotate, it knows how to rotate now. Even manage life, it knows how to manage it, right? Don't worry about this override keyword. I'll come to that in the last topic. For now, you just understand that the moment you inherit features from a parent class, you actually can have custom implementations over here. Okay. Similarly, suppose I create a Mars class, which is an extension of the same parent class, planet. So basically, you had the planet class, and I created a branch which says like Earth class. I have a branch called the Mars class. Okay, and Mars itself can have its own implementation of revolve, rotate, manage life, blah blah blah, anything. Okay, I'll come to that later. Yeah, so this is how you have the parent class and you have some implementations. Let me run this and show you what happens. So this is again the main function. I'm creating new objects here, Earth, Mars, and just printing things like Earth.parent, Earth.managelife, .revolve. Same thing for Mars. Okay, let me run this. Yeah. So here, as you can see, it says when I call name, okay, I mean Earth.name. Here again, I have declared it as public, so it is fine to access it for now. Usually you use getters over here, getters and setters. So it says the name is Earth, but then, I mean, yeah, the parent is Sun. And as you can see, we didn't do a custom implementation for the parent method, okay, because we had it already implemented in the abstract class as public void parent, and my parent is a Sun. Okay, so that was identically printed for both Mars as well as Earth. But then the other functions, like say manage life, revolve, okay, they were just declared in the parent class, never implemented. But then you did a custom implementation in individual definitions, and that is why you have it like I am Earth, I manage probably the only life form, and then I am revolving around the sun. Mars says, yeah, fine, may have life, see you soon, Elon Musk, things like that. And okay, so as you can see, you can have custom implementations, but under the same name. So this is the beauty of abstraction coupled with inheritance. Okay, got it. This is one way of inheritance. The other thing I wanted to show was there's another important concept. Yeah. So this is another example. It's a very common one. So you have this inheritance where, you have a class called animal, and I have done a basic field called a name. Okay. And yeah, so all animals move, right? So I have this implementation already defined in the class called I am moving, fine. And then we also know all animals eat, so that would be I'm eating now, fine. Then I have created 3 children classes of the animal class like this, like a monkey, a fish, and a dog. Okay. Now in the monkey class, as you can see, it is just a constructor and nothing else. Now, what does that mean? That means the other functions you had of the animal class, like the move and the eat, they are as it is taken by the monkey class. That means whenever you create a monkey object and call dot eat or dot move, the implementation will be that of the parent class. That is, I am moving and I am eating now. Okay. But that is not the case for fish. Why? Because now for fish, I extend it from the same animal class itself. But now I can have some new properties of the fish class, like the number of fins it has, the number of gills, the placement of gills, and whatever. Anything which is specific to fish, I can have it in the class of fish. Okay. And also I may have a custom implementation of the move method where I say, yeah, like I'm a fish and I swim. Here it is only printing things, but in real applications, you can have some other properties and other function calls and whatever. And finally, for the dog class, as you can see, it has a boolean called aggressive, but it also has a move method which says I'm a dog, I run. And you can see one important thing is that I have a new function called bark. Right? It wasn't there in the parent class animal. Okay, it had only move and eat, but now in the dog class there is this new method called bark. Okay, so that means you can have specific and custom properties fields, as well as custom implementations and custom functions for the child classes. And inheritance doesn't stop at one level. Okay, now you have this dog class inherited from animal, right? Then you can also have dog types like say pug, chihuahua, and other like anything. And under chihuahua you can have many other classes. You can have so many implementations. Like inheritance knows no depth. But there is a catch here. Now you saw, this is famously termed as a diamond problem here. You have the dog class, you have the fish class, but say you want to create a seal class, and we know that seal somewhat looks like a dog, but then it actually has functions of a fish, right? That means you want to combine both the features, but then the problem is once you try doing that, okay, like Java will throw an error saying that you cannot inherit multiple classes. Well, why is it so? Why should it happen that way? Because let me just show. You have something called as a move method, right? You have this move method which is there in dog, which is also there in fish. Now when I inherit properties from fish and from dog, which move function should be called when I say seal.move? Okay, which move should be called, whether it is of the fish or it is of the dog? This conflict arises, okay, when you have this particular when you're inheriting classes, okay, and that is the reason this diamond because of this diamond problem, it becomes really hard when you have multiple inheritance. Multiple inheritance is possible, but you need to take specific care, okay, as to which property you're trying to implement. And that specific implementation is a much deeper concept, okay, where here I am inheriting class. Instead of that, you inherit abstract classes, and to be more specific, you inherit interfaces. Okay, there is another concept called interface specific to Java, where it is an extension of abstraction itself, except that you cannot implement anything in an interface. It's just a simple list of functions. Okay, now when you inherit from interfaces, it is possible to actually do this multiple inheritance, but it is not possible with a class. Remember this. Okay, so that means this diamond problem arises where you have a parent class called animal, you got a dog, you got a fish. Now you're trying to get seal from both of them. Okay. So yeah, finally let me actually run and show that how this custom implementations function. So let me just run this. So for the we created the monkey object here, and we called two functions like move and eat, and it simply gave the output of the parent implementation. Then we created a fish object, and we called move and eat. Now, as you can see, move is custom implementation, but then we didn't give a custom implementation for eat, so it just inherited it from the parent class itself. right? But then for the dog function, I created a new method called bark, okay, which wasn't there in any of the other classes, and that comes up over here. Like I'm dog, and barking, maybe woof woof, I don't know, things like this. So, so the main thing you need to learn from abstraction coupled with inheritance is that you define a list of properties and classes in a separate class, which usually is an abstract class, or it usually is an interface. Okay, these are the two terms you use, and from that you create subclasses, and you make custom implementations in each subclass, and that subclass you can divide to major subclasses. So at any stage, you have a proper relational idea, like you have a hierarchical idea as to which class is is grouped under which other parent class. Okay. Yeah, so that is the whole idea where, yeah, as I said, there are a lot of similar fields and methods. You want to reduce redundant code. Just imagine why it is important to reduce redundant code. Suppose you didn't inherit these methods of eating and moving from the animal class. You had to do custom implementations in each and every class you form. Like say you write a class monkey, then you give one definition for name, and one definition for eating, one definition for moving, and that's the same with fish and dog. But the moment you inherit, you actually reduced your volume of code and improved the elegant nature and the cleanliness of your code. Okay, and with the moment you do inheritance, right, you also form this relational structure among the different classes, and this also means that you can have a proper tracing, okay, of your entire hierarchy of your data objects, and also that you can do predictive testing. So yeah, I'm focusing on the testing part in every module because that is a very crucial thing in software development, and you all must know how to actually test your code, not just run, like test with all corner cases, and that's a very important thing. So that is why with all these things, features in hand, you need to inherit them. So that's how you create a parent class, you create a child class, and the same thing. Okay. And here is another example where you have a vehicle which has some data like speed, max speed, cruise name, and it has some perform some actions. You create one abstract class called vehicle, just create multiple classes like child class like bike, car, truck, whatever. And car in turn can be inherited, SUVs and high profile cars, family cars, whatever, sports cars. Whatever. So this is how you can optimize your coding time and your development time by actually following these principles. Okay. So any doubts as such? Any doubts? All right. Yeah, maybe I'll wrap up with the last topic, and maybe we can have the doubt clarification at first. Fine. So moving on to the last topic of this episode is polymorphism. Okay. So where we have the same method. Okay. So what's the philosophy behind polymorphism is that you have same method name. You want to keep same method name for a functionality. Okay. Maybe like say adding two numbers. For a normal person, if you give you say him to add two numbers, it doesn't matter what you give him, whether you say 1 and 2 or whether you give some float numbers or whatever. He knows how to add. The same thing we need the same thing in our code. Okay, this is where polymorphism steps in. Similarly, whether you want to have a specific implementation child class where you use these methods called override, overload, all these things, and finally this static binding and dynamic binding. These things. Let me go to the code and finish it. So yeah. So yeah, in this I have taken the simple thing where you have this dinosaur. Okay, and then you have these three functions, the same name as you can see, like greet, greet, greet. But then you can observe that the arguments are different. The first greet has no input arguments. Second one has some message. Third one has two numbers. Okay. And with this abstract class, we know that we cannot directly use the dinosaur class. We must inherit it. I mean, we need to create custom classes. So that's why I created T-Rex class. which extends your dinosaur class, and I have written something called as an override greet. Now, what do I mean by override in the sense, as the name indicates, I'm trying to re-implement, okay, a parent implementation. So that is where it says T-Rex, hi human, and then maybe you also give a message and it says, yeah, hi human, so and so. And then maybe you give two numbers, it adds and it greets you. So that's a weird way still. And you can also have other custom implementations like my age, things which returns different things. Now, this way where we are defining same name but different implementations, right? This property is called static binding. Means at compile time, right? At the compile time, your objects, I mean, the compiler knows as to which of these methods greet is being called. Okay, that is differentiated based on the arguments you pass. Okay, and one thing you need to remember is the compiler cannot differentiate between two methods if if you have the same number of arguments but different return types. Okay, in that case, it is not possible to implement it because just return values do not differentiate your implementations. Okay. With that, we even have another class called bird, the same things. Okay, just the implementations are different. And I have an extra function called fly. Now, we saw static binding here in case of polymorphism where you have the same structure, that is greet, but different implementation, like polymorph. Okay. Now, these things are fine. Okay. But then what is dynamic binding in case of polymorphism? Well, let me go here. First of all, I create this list, okay, of dinosaurs, all dinosaurs. Okay. Now, as you can see, this dinosaur here is an abstract class. Now, you can say, how come we are using dinosaur here when we know that it's impossible to use it? Well, here we're not creating the objects. Remember, here it is just an indication, it's just an indicator that you're trying to use objects of the class dinosaur, which are the subclasses. Okay, so that is why in the all dinosaurs, I'm trying to add T-Rex, I'm trying to add birds. Okay, now this is possible because of inheritance. Okay, it is possible that even though your data type is dinosaur, you can pass in the data type of another type, like the T-Rex type, because your T-Rex is a child of your dinosaur class. Okay. Once you're done with this, I'm just doing one other step here where I'm simply printing out dinosaur dot my age. Now here it is very important to note that your dinosaur as such, okay, the dinosaur class as such doesn't have any implementation of my age. It's just an abstract definition. But then, how is it that your dinosaurs my age will be functioned, right? Now this is decided in the runtime because we are creating two different objects over here. Like you're creating one of the T-Rex subclass, one of the bird subclass, and at runtime it differentiates between the my age. Now which my age, whether it is of the T-Rex, whether it's of the bird, well, that is very simple because in runtime it gets to know that, okay, first it comes out the T-Rex object, then comes out the bird object. And that is why when you actually run this code, let me show this. Yeah, so when you run this, okay, it says that I have lived for 10,000, yeah, let's like 1 lakh. So that comes out to be from the T-Rex definition. See here, the T-Rex definition, we have this 1 lakh printed out over here in the T-Rex. And in case of the bird, right, we have this 50,000 thing printed out. So at runtime, your class is getting bound to the, your subclass is getting bound and is getting interpreted. Now, this is the beauty of dynamic binding, right? So this is also a form of polymorphism where you have the same dinosaur object, but different things are getting bound to it at runtime. Okay, so whenever you see things like same but different implementation, okay, these two words when you see, right, you just straight away say that, okay, this is polymorphism. This guy needs the same thing but different forms of it. Okay, this is the concept of dynamic binding. So yeah, that's it. Pretty much like this is the major concepts here, where one was static binding you saw, and one, and then you saw the dynamic binding. Sorry, I forgot to mention about the static thing here. As you can see, when you call this greet function of T-Rex, right? It says this hi human whatever hi home, but then when you call the bird's greet function, so the names are same, but then you had difference in arguments. So that's like 3 and 4. So it says okay, I did something, whatever, 3 and 4. So these are the major concepts behind polymorphism. Okay. And let me just see pretty much. Yeah, I mean, yeah, this is the last thing I think. So where you have, in case of static polymorphism, what happens is you override, okay, you override your parent's implementation. It's much like a remote, much like remote buttons, right? They are different buttons to different jobs. Basically, they are all buttons in the same device. Something of that analogy. And for in case of dynamic thing, sort function of C++ is the best example, where you pass in ARR like sort ARR comma ARR plus n, or sort vector dot begin vector dot end. Even that vector, it can be like a vector of pairs of ints or floats, anything. Okay, so where you have one entity and at runtime, it's actually decided as to what is the actual quantity going in. So even another example is where you have this document viewer, like you can open up JPG, PDF, PNG, or a juice maker, whatever. So I hope you got a good idea as to what was polymorphism from this. So yeah, I have mentioned some links over here to go through, and I'll add more links also. And yeah, pretty much that's it for now. These are the basic pillars of where you learned about encapsulation, abstraction, inheritance, polymorphism. So so let me just summarize at last. Encapsulation, in the sense you want to hide your data from foreign classes, and instead of just hiding, you also want to allow restricted access to your data. That's it. That is encapsulation. Abstraction is just that you want to give an abstract overview of your complex entity. That's it. Inheritance is where you have a parent implementation, you want a parent class with few implementations, you want to inherit those features and give custom implementations. Finally, polymorphism is where you have the same method, different implementations, but the same object with different binding. That's it. That's all summarizes your 4 basic pillars of object-oriented programming. And if you still don't get these things as to like why I should use all these things in my code, and for now you might feel that it's fine even if I don't use any of these things, but once you start writing large code bases, you'll try to understand like this is very important in case of designing and also optimizing your time, money, all these things. So yeah, pretty much this summarizes all the things of the major concepts. And yeah, any more doubts? I took a lot of time, maybe 10 more minutes extra. Yeah, open for any question. Yeah, one thing, all these codes, whichever I showed, I'll upload it in the same GitHub repository, the like DSC IIT BBS slash the OOP event, and you can refer it at any point of time. And if you have any confusions, you can just put it in the pull request or even in the Discord channel, which is create a Discord server. You can just post your questions there, and we'll be ready to answer. Any questions for now? We can just overload the methods in the same class, not override, right? That's right. That's right. Like you in the same class when you're talking, you overload stuffs. But when you inherit things, okay, when you're taking it from some other class, that is where you override things. And this overloading, right? It is more like telling it's more in C++, where you have this overloading of operators like say like the less than symbol. You can give a custom implementation of your own less than symbol when you are implementing. So these things are very much possible with C++ in overloading. And coming to your question, yeah, of course, like overloading the methods is in the same class. Overriding is when you take it from a parent class. You override the implementation. That's a good question. Yeah, anything else, guys? Okay, Q&A. All right. I think it is fine. Like in one event, I know it becomes a bit too much to get to know in one go. So if you can just revisit these concepts anytime, and yeah, one thing is one person like Ram Mohan, he did it. He did a pull request to the actual thing. He forked it and did a pull request. Good job, Ram Mohan. It's a good thing. Appreciate it. Like you pretty much got the thing idea of how to define a class and used Python. That is totally fine. So you actually did these things where you have defined some functions and you define some other features, and you also you as you saw here, I hope you actually got an idea of it, that these things like see apply brakes, stop engine, start engine, these are pretty common to both the classes. And I hope you understood that these things can now be set up in a parent class, and from that you can actually inherit these things. Okay, like this is why this assignment was given. The solutions of this will soon upload it. Like we saw, there was only one pull request, so that's why we waited. And now in the coming week, we'll upload the solutions of this also. And for this event, the problem statements will be putting it up soon, maybe by today or by next 2 days. You can also go through those problem statements, and whatever code bases I have here, like of all the implementations, I'll upload it, and you can refer it as and when you need it. And there are also a lot of resources mentioned, and I'll fill in more resources, and you can also go through that if you have more confusions. And remember, please be thorough with these concepts. They play a major role when you're giving your interviews and doing an also an internship. These things, it gives you an upper hand. Right? Okay.
Yeah.
Yes, Ashley. Yeah.
So thank you for the great session. Thank you all for
Yeah.
attending,
Welcome.
and hope everyone will be there for our future sessions as well. So, okay, we can end this session now.
All right. Thanks, guys, for